Graph the following function using the techniques of shifting, compressing, stretching, and reflecting. Start with the graph of the basic function. Find the domain and range of the function. We want to do that with g of x equals 4, absolute value of 3 minus x. So what I'm going to start with is rewriting the inside of this absolute value. So we're starting off with this g of x equals 4, and I'm going to rewrite those terms so that it's negative x plus 3. I'm doing this so it matches the format of the transformations that we have memorized. I'm also going to factor out this negative. So if I factor out the negative, I'll have x minus 3. Negative x minus 3 inside that absolute value. So now that I have it in this format, I want to identify the base graph, and the base graph can be identified with those absolute value bars. We know that we are starting with a basic function of y equals absolute value of x. We know that the graph of y equals absolute value of x is a V-shaped graph. It comes to a point right at the origin 0, 0. And then from there, I want to identify these different transformations. We've got this 4, this negative, and this minus 3. These are 3 transformations that we've got to apply to the basic function of the absolute value graph. So let's figure out what those different transformations are. So we have this multiplication by 4. We have a multiplication by a negative 1 and a subtraction of 3. So when I think of the big categories of transformations, we have the category of shifting, and shifting is going to happen when you have adding or subtracting within your equation. So I only have one subtraction, that's minus 3, so that's going to be a shift in the graph. Then the next category of transformations is stretching and compressing. And stretching or compressing happens when you multiply by a number. So it's multiplication by some number. So that multiplication by 4 is going to be either a stretch or a compression. And then our final category of transformations is reflecting, and reflecting is going to happen when you're multiplying by a negative 1. So we've got multiplication by a negative 1, so we have a reflection. So I've identified the big categories of what these transformations are, but there's a lot more details to figure out, because there are vertical stretches and compressions, there are horizontal stretches and compressions, so we need to figure out which type this multiplication by 4 is. With reflections, there are 2 different types. You can have a vertical reflection or a horizontal reflection over the x-axis or y-axis. And for shifting, you can shift left, right, up, or down. So we really need to narrow down which type of each one of these we have. So one thing we can pay attention to is whether the transformation is occurring inside or outside of our basic function. So our basic function is that absolute value. So we're going to look on the inside and on the outside of the absolute value bars. So the 4 is outside, the negative is on the inside, and the minus 3 is on the inside. Transformations that are on the inside will be horizontal transformations, and transformations that are on the outside will be vertical transformations. So we know that our stretch or compression will be a vertical one, and our reflection will be horizontal, and our shift will be horizontal. So that narrows down. The reflection is a horizontal reflection, meaning that it reflects over the y-axis. And we don't need any other details about that transformation. Now, with the stretch or compression, we need to figure out which one it is, whether it's a stretch or compression. So with vertical stretches or compressions, we pay attention to the value that we're multiplying by. And if that number is greater than 1, we call it a stretch. And if that number is in between 0 and 1, we call it a compression. So in our example, because the number we're multiplying by is greater than 1, it's a stretch. So we now know that we have a vertical stretch by a multiple of 4. And then with our shift, we have a horizontal shift that's either left or right. And moving to the left would be a plus, and moving to the right would be a minus. So because we have a minus, we know that our shift is going to be to the right 3. So we can now use these transformations to draw the graph of this basic function. So if we start off, I'm going to start off by graphing our basic function y equals absolute value of x. I'll graph that in black. Then I'm going to graph y equals negative absolute value of x. That's going to be, let me choose a color for that. Let's see, I'll graph it in this orangish color. And this is going to show our horizontal reflection. So then I will graph y equals absolute value of negative x minus 3. And this is going to shift our graph to the right 3. And then finally, I'll draw the graph of y equals 4 times the absolute value of negative x minus 3. And this will include all 3 transformations. So the graph of absolute value of x is a V-shaped graph starting at the origin. And so it looks like this. And that first transformation, which is the horizontal reflection, is going to look like we didn't change anything because this function is an even function. It has y-axis symmetry. So when we mirror over the y-axis, it looks exactly like it started. So then I'll shift all of those points to the right 3. And we get this graph in the light blue. And then I want to multiply by a factor of 4, stretch out the graph by a factor of 4. So instead of this going up to 1, it's going to multiply by 4. And we get this stretched out graph here, vertically stretched. So that gives us the graph of g of x equals 4 times the absolute value of 3 minus x. Thank you for checking out my videos. Have a great day.